So I've got a simple deployment with two regions, an Americas and a Europe. And within the Americas region, it's hub and spoke. I got a west branch down here, an east branch, east hub and a west hub. Now, these two hubs in this east and west, they're all in one region. That's an important point. That makes these two redundant for each other. If I'm on the east branch here, 10.1.2.0, and I want to talk to 10.2.2.0, I want that traffic to leave east, go to east hub, go to the east Europe hub, and I want it to come back to the east hub into the east branch. Each branch, each hub, every EdgeConnect, in fact, has this peer priority table. And you put in that table the name of a peer, usually one of your other hubs, like in the case of the east branch down here, we have added a east hub peer priority of 10. So what this does, though, is it says, all right, east peer priority 10. So my east branch here is going to, if all things are equal, if I'm receiving the same metric and whatnot from the east hub here, 10.2.2.0, then I'm going to prefer to route toward this guy, east hub. So my packets are going to leave the east branch. They're going to go to my regional hub here, the east hub. We're going to add 50 to the metric, and then the traffic is going to make its way to the Europe hub. So good so far. But now the return path is where we run into problems. The Europe hub here has two choices. It can either do no peer priority, just not set a peer priority at all, which will result in load balancing. It'll result in equal cost multipath load balancing across both east and west to get back to the east branch. And that's because if you look at the metric here, the east branch is announcing metric 50 to the west, and it's announcing metric 50 to east. West adds 50 more, goes to 100. East adds 50 more, goes to 100. Now the Europe hub here has two routes back to the east branch with exactly the same metric and exactly the same prefix. So we will ECMP. If now we say, all right, I'm going to try to fix this. I'm going to go to my east hub and I'm going to specify, west hub peer priority 10 and east hub peer priority 20. Well, now west is going to work just fine because he's going to send traffic. He's got peer priority set to 10 for the west hub. The traffic will go to the west hub. It will then go to Europe. And then because Europe has a peer priority of 10 specified for the west hub, the traffic will return back symmetrically every time. But what happens if you're on the east branch? Well, the traffic, same thing. Our outbound goes to the east hub. We route to the Europe hub. Now the Europe hub does a lookup and says, west hub has the higher peer priority, and it will send the traffic back to the west hub. You need a way to instruct the Europe hub which way to go when you're trying to get back to either the east or west branch. And that is what this feature does. There's a new column that's been added to the peer priority table. So this is the one that's always been there. This is in this case, what we're saying here is that if you're in the US Southeast region and you have this template applied to you, your preferred regional hub will be East 3-Google. And more importantly, when you send routes to East 3, we're gonna default the subnet metric to 40. That will cause any routes that I send to East 3-Google to be slightly better than the routes that I send to all the other hubs. So preserve existing means use whatever the default metric is for all the routes, which is 50 by default in our system. So advertise metric is controlling the inbound, peer priority is controlling the outbound. Now, notice these metrics here. The routes are leaving the branch with the assigned metric. So basically we're saying, if you send routes to East Hub because of the advertise metric I've configured, send 45. If you send the routes to anywhere else based on, just let's say I say preserve existing, the metric will just default to 50. So now let's carry that forward from East toward the Europe hub. Here, now it'll be 45 plus 50. So this guy, Europe hub, will receive 95, and West hub received 50 here. So it'll add 50 more. This would be 100. So now the Europe hub has a decision. It says, all right, I need to go back to 10.1.2.0 on the East hub. it does a route table lookup, and it finds that for 10.120 East Hub, the metric is 95, which is better than what you have from the West Coast hub of 100. And so in both cases, the blue and the orange, the European hub now knows how to route back into the Americas region on the appropriate hub for a given branch.